All right, guys. I'm only going to do the second page because first page we would have done in class. So let's take a look at some of these just in case you're still having a hard time with these. It says reflect across the x-axis and translate 4 units to the right. Now this one I could put the I could definitely put the coordinates on there, but when I translate, I'm just going to kind of in my head know that I'm using the x-axis as the mirror, or if I reflect. So here's the mirror right there. There's the x-axis. So if this one has to move down 1, 2, 3, 4, 5, 6, then I'm just going to move down 6 on that same line and move down there. This one had to move down 2, so on the same line, I'll move down 2, 2, and it looks like 6. And that's where I would have reflected to, and I could have done it really quickly, just like that. And I reflected across the x-axis. Now it says move 4 units to the right. Okay, I can do that. I'll do it in a different color. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, and I'm done. That's where it moves to, right there. So hopefully when you reflect, you don't spend too much time. You just kind of, in your head, flip it over that correct axis. If you want to find the exact points, you can put them in. We know the technique to do that too. This says reflect across the y-axis. The y-axis is this one that goes, that's the mirror. So if that's the mirror, this one's like 2 away from there, so it would flip 2 this way. This point is just 1 away, so it would just be 1 away. This point is 1, 2, 3, 4, 5 away, so it'd be 5 away over here. This one is 1, 2, 3, 4, 5, 6, 7 away, so it would be 7 away over there. And there's our new shape. So it flips across the y-axis and 6 units down. Okay, I can do that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, notice the shape. It has flipped over, like the first time it flipped over, then the second time it doesn't flip over. We're just translating it 6 units down. The shape doesn't get any bigger, it doesn't get any smaller, none of the angles change. This side right here is the same size as that side right there is the same side as that side right there. It doesn't get bigger, it doesn't get smaller. It's the same shape, just flipped over and then slid down. So on a test at the end of the year, they're going to ask you if, like, are these sides still the same size? And yes, they are. All right. This one I do need to know the points. This one is -9, -1. This one is -4, +8. Oh, sorry, not -1, +1. I'm going to erase that. -9, +1. And this one is -3, or -1, +3. Okay, so I'm going to rotate clockwise, which means I'm going to move from this neighborhood up to this neighborhood. And this is like the super rich part of town. Everybody in this neighborhood has a positive for their start of their address and a positive for the back of their address. So all of these numbers, once we move, need to have a positive and a positive number. Remember, when we move, it flips your whole life around. Moving sucks. So we're going to switch the x and the y whenever we rotate to a new neighborhood. So, okay, so this -4, 8 switches to 8 and in the front, 4 in the back. So 8 in the front, 4 in the back would be right here if both are going to be positive, 8 and 4. Okay, we're moving to this neighborhood, and we'll switch 9, 1 to 1, 9. And they're both positive because they're in this neighborhood. And -1, 3, we'll switch to 3 and -1, but let's make them both positive, so 3 and +1. And there's our rotated shape. And we rotated it into that neighborhood. And we can see that this kind of rotated down to there, this rotated to there, and this rotated over to there. Okay. Dilate by a scale factor of 1/2. Well, when we dilate, we do need to know where the points are. So this one's at 4, 8. This one's at 10, -6. This one's at -4, 10. And this one is at -6, 2. Okay, dilate by a scale factor of 1/2 means we're going to multiply every number by 1/2. Basically, we're going to cut every number in half. So I'm going to, instead of 4, 8, we're going to be at 2, 4. I just cut the numbers in half because the scale factor is 1/2. Instead of 10, -6, we're at 5, -3. Instead of -4, 10, we're at -2, 5. Cut them both in half. And finally, instead of -6, 2, we're at -3, +1. And there's our new shape, cut by a scale factor of 1/2. So it actually got pretty much half as big. It's not quite half, but it's half as big for all intents and purposes. Let's see, did I do that right? Everything looks pretty good. Why does something -6, 2, why does that look a little bit off to me? 4, 8, 2, that's why it looks off. Something didn't look right, did it? 2, 4. Something didn't look symmetrical about that line. I just put it in the wrong spot. There we go, that looks better. Okay, yeah, there's that one. Finally, rotate 90 degrees clockwise. Okay, we're gonna move down here clockwise this way. This neighborhood has a positive for its first number and a negative for its second number because you have to move positive to the positive and then you have to move down. So positive, negative to get to this neighborhood. Okay, so we're moving, so we're gonna switch the numbers and make them positive/negative. Okay, let's see. This one is at 3, 6. This one's at 8, 8. This one's at 6, 1. All right, let's switch them back and forth. When we rotate to a new neighborhood, moving sucks. It switches you, turns your whole life around. So instead of 3, 6, we're gonna go to 6, 3, but 6 this way and 3 down. So 6, -3. Instead of 8, 8, well, switching back and forth, we're still gonna have 8 and 8, but +8 and -8. And then finally, 6 and 1, switch it around, 1 and 6, but +1, -6. And there's where this shape rotates to. Let's see, +1, -6. But then it says, and translate 10 units. Ooh, right, I meant to say left. Sorry, if you're watching this video, left. Okay, I'll make sure, sorry, period 1, I didn't tell you, I'll tell every other period. So let's do that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. So we rotated it, and then we just translated it left. And that's where it goes to. Okay. And finally, dilate by a scale factor of 2. We've got 3, 3. We've got 0, -5. And we've got -2, 1. Just multiply everything by 2 because the scale factor is 2. So we go up to 6, 6, -4, 2. And 0 still because 2 times 0 is 0. And then -10. 0, -10. And we'll see that this triangle basically got 2 times bigger. All right, so there we go.